right? So Planck's constant. We know that Planck was desperate to figure out um, the radiation, ultraviolet catastrophe, the behavior of energy given off based on temperature and so on. And he just decided, okay, well, let's if energy was quantized and it was proportional to the frequency and so on, um, equals h bar. Oh, it's a v there instead of an f. I didn't notice that where I grabbed the picture from. But anyways, the h bar, or not h bar. Oh, I always say that by accident. Planck's constant is just h. H bar is when you divide by 2 pi, as you saw in previous videos. Anyways, Planck's constant 6.62 ish times 10 to the negative 34. It's a crazy small number, and so it's even crazier that we can measure it, right, in a high school lab that I've done in the past. So thanks to the Perimeter Institute, I was at a conference thing a while back, a long time ago, and someone mentioned about how that how you can the high school lab where you can measure Planck's constant, and so I immediately was like, "Wait, the what now?" and tell me more. Anyway, so the Perimeter Institute is this theoretical physics research institute in Waterloo, and they have Stephen Hawking's been there. They have high end theoretical physics research going on from people from all around the world that are working there. Um, and they're working on quantum computing and dark energy and dark matter and all sorts of, it's a theoretical research, physics research institute. In a previous video, actually, there was a room with little red couches and so on. And I just recognized the room when I was there because it was so bizarre looking in the video. And I saw it. I was like, hey, I've been there because I was there for a physics teachers conference one year. Anyways, so there's a lab, and so they provided materials for people, and it was a potentiometer, which is kind of like a dimmer switch, and a bunch of LEDs, and yeah, and sort of an instruction manual, if you will, of how to do this, right? So I was going to make a video showing it and giving results of what the measurements would look like and so on. And I found this video of a physics teacher's made the video that I was thinking of making. So I'll just leave it for you to look at and go through, but you'll get data from the video. And it goes through, explains all about it. I'll give you a little bit of a spiel about it here too, though. But the main idea is that the first light, they call it. So when light first starts to get made given off by an LED, then the voltage has to do with the energy and that's making that happen. And of course, the color of the LED is to do with the frequency. And so you've got an energy frequency relationship being measured, which is what we're looking for here, right? So if I were to the way here, I'm going to change that to be an F soon here, but maybe I won't do it while you're waiting. Anyways, so you gather a bunch of information, right? So when we apply a voltage potential difference across, right, you have a voltage and energy and a frequency and so on. And so just go through the ideas here and follow that video and go through it. I gave the actual handout, and if you're in a class, this is would have been the wiring diagram to hook it up and the steps and so on. Obviously, you're not really doing all that, but you're going to get the information from the video, and you're going to plot energy versus energy versus frequency essentially, and yeah, so the calculations are carried out there as to how that would work, and what you need to do, and so what you're going to be doing, you're going to be getting it says here, calculate the slope, right, of the line of best fit using some kind of program. It could even do it by hand, I suppose, but I mean, there's lots of graphing analysis tech available. Desmos, GeoGebra, even whatever you can use. If you need a tutorial on that, well, honestly, just Google it, but I can probably find one for you too if you need. But in Excel, for example, you just highlight the points and right click on it and go add trend line and so on. So that might even help you enough. Yeah, and so then some questions go along with it, and it's just kind of a neat thing to see that you can do. So yeah, go through the video, and he's just showing here. I'll show a little bit of it. Add first, apparently. I'm watching another ad now. It's been a wee bit slow this morning.
Hi, welcome to Physics Teacher. In this video, I'm going over a lab that I do with my grade 12 physics
tailor-made
students.
for
I have
us
a
here, right? So it shows the
potentiometer,
wiring,
which
and
I can
whatnot.
use to
Even talks about what LEDs
start
are.
to see light coming out of the LED.
And
when that
kind of
happens,
neat to see what an LED really is.
first one's
It's,
an
you may have
N-type
heard
semi.
it talked about in chemistry class when you look at metalloids. So objects that have metal and non-metal properties depending on situations. And anyway, so he goes through and he measures, measures a red light and tells you the color, and eventually shows you the voltage of the first light. You just gather that data and make your graph and measure H. So measure the Planck's constant, which is pretty cool that we can do it. Okay, so I just wanted to share this with you so you can see the idea of what is possible. Okay, and that is all for now. Let me know if you have any questions. Thanks for watching.